Okay, if we can just spend a few minutes to finish up page 10. This is the last page that we were working on. I just had us try part A, where we did top minus bottom, but we worked it out by hands, use substitution, taking antiderivative, evaluate the upper and lower bounds. Just know that you can't have trig showing in your final answer if you're dealing with, especially if there's unit circle values that where we can find the ratios. Again, on the test, you'll get to use your calculator, and after the setup, you can just plug in the calculator. But we went through that exercise yesterday, and I don't want us to forget the process of working through. Okay, so that's part A. Part B is a rotation problem. Decide whether it's going to be this, the washer method, and then part C, you have a cross-section problem, volume by cross-section. Okay, so part B, we see that there are no flat surfaces on this graph, so there's no chance that this could ever be this method. So no matter where you have the axis, even if it's touching, there's going to be a gap. So we know it's going to be washer method. So we do top minus bottom. We start on the axis. We extend to the furthest boundary of our shaded region, and we look at where the top of the radius is touching, what the bottom of the radius is touching. We subtract those two. So in this case, big R is sitting at the dotted line, which is 4, minus the bottom function is the 2x squared. Now, I think some students were asking, how do you know which one is which? How do you know that this is cosine and this one is x squared, 2x squared? Well, we know what 2x squared looks like, right? We know that 2x squared has a parabola shape that opens up. That 2 just stretches it out, but you know it's going to be concave up. So the only concave up graph that you see is the one that's below, right? The cosine graph is the one that goes through that y-intercept at 4. Okay, careful with the parentheses, right? Top minus bottom, we have to protect the bottom function with a set of parentheses, distribute that through, combine like terms. I get it down to a cleaned up R of x, big R. And the little radius, top minus bottom, the top of the little radius is sitting at the y equals 4. The bottom of the little radius is sitting at the cosine curve. So 4 minus 4 cosine pi over 4x. Okay. Once you have your big R and little r, you can put it to your just washer method formula. Volume is pi, definite interval from 0 to 2, because we're stacking these circular discs from this side all the way to this side, right? So we're looking at x values. Okay. And also a reminder is that you see x values, x variable here, so I have to use x variables here. I can't have y variables here and x variables there. Right? I got to have, you know, everything matching with the same variable. Okay. Any questions with part B? Part C. The region R as the base of a solid. For this base, each cross section is perpendicular to the x-axis. So we know which direction to draw our baseline. And then the shape that we want to build is a square. And then right foot do not evaluate expression that gives the volume being solid. So we're going to draw in our base length, either horizontal or vertical, and then from there we can find that expression that represents that length of the base. We put it into the area formula for square, and then after that we extend that to a volume formula with the integral notation. Okay, so perpendicular to the x-axis, that's another way of saying vertical. So top minus bottom, top is sitting at the cosine, bottom is sitting at the polynomial. Formula for area is the entire base squared. B is volume is definite interval from 0 to 2, so we're stacking these squares from the furthest left to the furthest right. And there's no pi in front, right? So it's a little bit like this method, but we're building squares, we're not building circular discs. Thank you. Yes. All right, any questions here? All right, so a couple of things. Your tests will look a lot like pages 11 through 13. If you look on this review worksheet for him, saving this to go over tomorrow morning during the tomorrow morning help session at 7:15. So it'll look a lot like this, where I'm going to draw the graph for you, but you're gonna have to find the intersections using your calculator. I do want to point something out here that some students were asking, oh, what if something is all the way to the right and it's further out? You can either use zoom out, but with zoom out, you really don't have much control as to how far zooming out. So let's say you want to get that graph to stretch out a little further to the right. You're not quite seeing what's showing to the right. You can go to window. You can adjust your how far left, how far right, how far up, how far down you want the graph to go. So -10 to 10 means you're only showing from -10 to 10. But let's say the graph is further to the right than what you are expecting. Then you can always change your X max to like 50 or 40 or whatever you want. So you can always self-adjust how how you want your graph to look. But we also, but usually when we zoom in, we like to use that zoom box feature. So we just put a box around what we want to look at, and they'll just zoom in without having to worry about, wait, I want this to go to, to -5 to 10, right? So, zoom out is another option for getting a bigger picture of the graph. But again, you don't have much control as to where they're zooming out. But I think between zoom in, zoom out, box, Z box, and then playing with X min, X max, Y min, Y max, you should be able to see exactly the graph that you want to see. Okay, you'll get to use your calculator. Typically, students find this test a little bit on the shorter side, and some students, if you know how to find those bounds, the area, distinction between area, volume, and cross section. There's not a whole lot of work to do, right? Because once you set up the formula, then the rest is just calculator work. Encourage you guys to work through beforehand if you have time. That way you don't have to wait till tomorrow to do all these problems. But that's up to you. And also make sure you review your formulas, right? So you got area formula for top minus bottom or right minus left. This method for top minus bottom, right minus left. Same thing, two versions of washer method. And then you got cross section. And cross section, you just have to spend a little bit of time kind of memorizing these formulas. Just remember that most everything is base squared. You just have to remember the coefficients that's in front. It's 1/2, 1/4, √3/4, or power of 8. And the rectangle is just base times height. Okay, any questions about the test for tomorrow? Okay, I'll send out a reminder this afternoon and make sure you bring your calculators tomorrow as well. All right, I want to spend a bit of time talking about our calendar for the remainder of this semester. Does anyone not get a calendar from yesterday? Okay, so we're going to have homework every day, but the homework points are going to go directly into a test or quiz grade. And so every homework that you do, it's going to be working towards a quiz or test grade. So, for instance, today we're doing pages 1 through 3. We're probably going to be able to finish it in class. If we finish in class, then that's great. You've earned your 5 points, and I'm just going to be checking on Monday. Okay, and then Monday we'll continue with the packet, pages 4 through 6. If we finish those, then great. I may do additional problems beyond that, but you're only responsible for what I have here. So what I'm checking for is a mixture of classwork and homework. Sometimes we can get through everything in class. Sometimes we can't. If we can't, then you'll just finish whatever is required for you for homework, and then I'll be checking that the following day. Okay. If you're late on any homework, then the most I will deduct is 1 point. So let's say for this day, you didn't show it to me until Thursday. I'll make it 4 out of 5 points, right? But let's say you didn't get it done until the following week, it's still 4 out of 5 points. So if you're late on every homework, you can still redo everything and you'll still get 80% out of all your homework. But ideally, if you just do your homework every day, you're getting those maximum points. That's going to go towards your test or your assessment. So we're having our first AP assessment next Friday, and we'll be spending these 3 days going over exactly where you're going to see. And then whatever you get on that quiz grade is out of 50 points. And then all the homework that you did up to that point is also 50 points. So it's going to add up to be a 100-point quiz grade. Right? So basically all the homework that you do is going to be half of the next assessment grade that you take in class. So it creates a nice buffer for, any low grade that you have on the quiz. Your homework will balance that out. Okay. And all the homework that I assign, I'm also giving you the key, so you're able to work alongside it, or you're working through it first and then you're doing corrections. So when I'm checking for homework, I'm looking for work, right? So if you just show me the answers, I may ask you to do more, or maybe you just are to do everything in your head. If you can, then I may just ask you to explain a certain problem to me. So I know that you understand that process and that you're not just writing something down without spending time on it. Okay, so I'm just looking for you to show me that you spent time on the problem with the amount of work you're showing on paper. Okay, and I'm also expecting you to do corrections on if you're working through it beforehand without the key, and then you look at the key, you can do corrections. That's what I'm looking for as well, that you're spending time on the problem and that you're understanding if you made a mistake, why you made the mistake. Okay. So the packet in your hand, that will take you to next Friday, and then I have a second packet with AP review topics. And we're going to have another FRQ quiz 2 weeks after spring break, just over Riemann sums and differential equations. And then we'll do a multiple choice review homework alongside that as well. And this will be a test grade. So your multiple choice test will be split into 2 days. And the reason why is because it's only a class length test, but it's split into 2 days because this is during EOCs. So EOCs, the class period will be cut to like 35 minutes. So you'll have 8 multiple choice one day, 8 multiple choice on the next day. And then each multiple choice section is 25 points, plus all the homework. So that's going to add up to be 100-point test grade. Okay. Now, after that, your AP exams begin on May 1st. So I know that students are going to be in and out of the classroom, which is expected. But there's 2 more assessments, and that is working through the FRQs and then working through 2 multiple choice tests. Okay, but there's no late penalty for any of these grades. Okay? Ideally, I would like for all students to finish everything by Friday or Saturday or Sunday, so they can kind of see everything before the AP exam. But I also know, with everyone's schedule, I can't fully expect that. So, if you're late on these homework assignments, I completely understand. You just show it to me whenever you can. Okay, and you'll still earn full credit as long as you show me all the work. Senior last day is on the 12th. Grades are due. I'm going to say grades are due on the 15th. Maybe it's on the 16th, but I would like to have it on this day so I can enter it in and update all your grades. And then everything else after that is just going to be makeups, help sessions, any assessment recovery, any students who need to bring their grade up to a passing. We're going to spend this time doing that. Okay. And then finally, here are the summary of the grades that are going in the grade book after this Chapter 7 test. So we have the FRQ Quiz 1, which is coming up next Friday. We have FRQ Quiz 2, which is 2 weeks after spring break. We have the multiple choice test, which is split into 2 days during the EOC week. And then 4 and 5 are just FRQs and multiple choice tests. Now, I do want to give this to you early in case you want to kind of work through it over time. You can show it to me as late as you want. You can show it to me as early as you want. But I will try to get these to you earlier so that you're not waiting until so that, you have the opportunity to do it before, AP exams start. In fact, that would be great if you can work through it. Now, if you're in class here, I will be going through specific problems from these FRQs. But I also understand students are in and out, so I'm not expecting a full class during that week. Okay. So take-home assessments can be turned in at any time until May 15th. Be sure to show all of your work as well as corrections from keys in different color inks. So that's the hope that you can, the more that you see, the more that you do, the more comfortable you're going to be with AP exam coming up. Also understand, with first period, you potentially have less time during the day to show me all your work. So if you're not able to show me your work by class period, you can show it to me later in the day. You can come by later. End of the day, show me the homework. I'll still give you full credit. As long as you show me the work the day of, you won't lose any points. Okay. All right. Any questions? There's a lot here, but any questions with the grading or with what's expected or what's coming up? Okay. All right. So let's go to our AP first packet. All right, so this is not going to be on the quiz that I have for next week, but it is very important because these are very specific FRQ problems that we haven't quite seen yet. So I want to kind of spend some time. Hopefully, I can get through at least 1 and 2. So we'll see. Okay, so I do want to mention a couple of reminders conceptually is with units of measure. Okay. Whenever you find a derivative, you're introducing more denominator rates, right? So if velocity is meters per second, then acceleration, which is v prime, will be meters per second, which is meters per second squared, right? You're applying a derivative, which is a rate of change. And if you're finding slope, you're always doing a divisional feature to it, right? So if I do change in velocity over change in time, that's going to give me velocity over time, which is velocity, which is meters per second, meter per second squared. So you're always adding more units to the denominator each time you find the derivative or each time you do the rate. Likewise, if I'm going the other direction, right, let's say velocity is in meters per second, then the antiderivative of velocity will change to a new unit of measure in meters, since the accumulation of rates will be the result of the new unit of measure giving us displacement. So here's a way I think could help is understanding that, v of t, if v of t is meters per second, and then dt is also time measurement times second. So what happens if I do meters per second times second? It just turns into what? Not meters per second squared, just meters. Why? The seconds cancel out, okay? So it becomes meters. So if you're ever kind of struggling as to, wait, what is my new unit going to be and what is it going to tell me? You look at the units for whatever you see here, and then you're always going to be able to know what unit that you're dealing with here, and then you multiply those two together, and that'll give you your new units. Right. All right. So for instance, if I travel 60 miles per hour over a 5-hour period, then 60 miles per hour times 5 will give me 300 miles. Right? So basically, if I'm accumulating my rate over a 5-hour period, that's the same thing as saying the integral from 0 to 50 of 60. Right? Because I'm accumulating that 60 miles per hour over a 5-hour period, which is 300 miles. So, I know that this makes sense to us because, if you're ever traveling on a road trip and you're saying, okay, if I'm driving 60 miles per hour, if I'm going five hours on that trip, how many miles will I cover? 300 miles. So you can write it also in terms of a integration problem. Okay, it's just that's a nice constant. So 60 becomes 60t. You plug in 5 and 0, you still get 300 miles per hour, or sorry, 300 miles. Okay, so let's read this problem here and kind of make sense of it. So number one, it says the rate at which people enter an amusement park on a given day is modeled by the function E, defined by E of t. So this is the rate at which people are coming in. So maybe, at 9 a.m., there's 200 people per hour coming in. But then by 12, maybe 500 people per hour. But maybe by like 5 p.m., it's, down to like, -4 people per hour because more people are leaving than coming in, right? Or the rate at which people are leaving the amusement park is going to be pretty small at the beginning of the day, with that we would expect, and then at the end of the day, you would expect that rate to be increasing, right? Maybe it's 1,000 people per hour at 5 p.m. because it's getting close to the end of the day, and so you see more and more people leaving. The rate at which people are leaving is going to become higher and higher as the day progresses. Okay, both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. So these functions are valid between 9 and 23, so 9 a.m. to 11 p.m. Okay, the hours during which the park is open. At time t equals 9, there are no people in the park. Okay. So part A says how many people have entered the park by 5 p.m., which is t equals 17. Okay. So we know that we're going to be involving integration, right? Because this is E of t is in terms of people per hour. But I want the total number of people. So if I want to take that E of t and make it rise up to the number of people, I got to do what to E of t? Take the what? Take the integral, right? Because the integral will allow people per hour times hour to turn into the number of people. Let me just show a quick, easy example before we get into something that feels complicated. So let's say, let's just say for an easy example, let's say there's 100 people entering the park per hour for all throughout the day. Okay, 100 people per hour is that constant rate. So over a 5-hour period, how many people would be in the park? 500, because you know that 100 people per hour. Every hour that passes, I'm going to keep adding 100 people, 100 more people. Okay. So if I want to put it into integral form, it will be the integral from 0 to 5 of 100 dt, right? 100 is people per hour. And then time is in terms of hour. If I multiply people per hour times hour, I'm down to people. All right, so I want to keep reminding us that, when you take the integral, your units are going to change, right? This is no longer going to be people per hour. It's going to be people. But if this is people per hour, then it'll become people per hour, right? So just keep reminding yourself, if you're having trouble deciding what the units are, just look at each of your expressions and just multiply those two units together. If you multiply those two units together, you're going to arrive at the new unit that you're supposed to be in. Okay, so then part A says how many people have entered the park by 5 p.m. Okay. Entering, we're just dealing with E of t. So I'm going to take the definite integral. From 9 to 17, because that's 9 a.m. to 5 p.m. of E of t, right? So this is people per hour. This is hour. People per hour times hour will give me the accumulation of all the people who are in the park between those hours, or who've entered the park in those hours. All right, so we can practice entering this in our calculator. Again, I like to do under y1 and y2, so I don't have to deal with all these parentheses and fractions. So I'm going to let y1 hold my E of t. So we do alpha y equals, I can get that fraction to show up. I see t squared here, but I'm going to only use what in the calculator? Only x, yeah, so x squared. let's exit out, get back to the main screen. Math 9, depth to integral. Okay, my E of t is stored under y1, so alpha trace. I can select my the place where I stored E of t, which is under y1, and then dx. So we're going to round to the nearest person here. So about 6,004 people have entered in the park between the hours of 9 a.m. and 5 p.m. Okay, any questions with A? Okay, part B, the price of admission to the park is $15 until 5 p.m. After 5, the price of admission to the park is $11. How much are collected from admissions to the park on that given day? Okay, so there's a split, right? So the number of people who've entered in the park up to 5 p.m. is charged at a higher rate than those who entered in the park after 5 p.m. So we can do two different integrals, right? How I can take this integral here and multiply it by what? So the 6,004 people, they're all going to be charged how much? $15. So I'm going to you can just write that times 6,004, but I'm going to write it out with integral notation. So this represents the number of people who've entered in the park who I'm going to be charging $15 per person. This will give me my revenue plus, and then the $11 is going to be integral from where to where. How do I find those numbers of people? I'm sorry, 9 to 17, my bad. Yeah. So from where to where, from when to when? 17 to 23, because that's when the park closes, right? Still E of t, I still want to count the number of people who've entered in the park. So we do a separate integral here. We'll find the number of people here. We already know this is 6,004, so we do 6,004 times 15. I also want to find the number of people who entered the park in this second time period and multiply that by 11. And just based on how you round, you either round the person up or down. I think anything in this range, you may have a slightly different. If you do 1, 2, 7, 1, that's going to throw off your answer a little bit. So as long as you can set up your integral and the rounding is debatable in terms of will you round down or do you round up? All right, any questions there with A or B? Okay, part C. It says let h of t be the integral from 9 to t of e of x minus L of x. And the value of h of 17 to the nearest whole number is 37.25. So let's build this out here. So for part C here, h of t, integral from 9 to 17 of e of x minus L of x. The value of h of 17. So I'm going to try this here, h of 17. What does that mean? I can put 17 in for what? I'm sorry, 9 to, my bad, 9 to t, right? This is 9 to t. Okay, but h of 17 means I'm going to plug 17 in for t. And I want to do this here. I want to separate it out so we can kind of have a better idea what this means. So let's break this apart, right? What does this notation mean? Well, E of x is per people per hour, but if we accumulate that rate, this will actually be what? Yeah, that's right. Number of people who've entered between what? Yeah, 9 and 5 p.m., right? So what do you think this represents? Number of people who've left the park, yeah. So what are we left with then? What is this information going to tell us? What's h of 17 going to tell us in terms of in relation to basically what information does this provide for us about the park? Yeah, how many people are left in the park, right? How many people are left, right? So if I count all the people who've entered in the park, and if I subtract all the ones who've left the park, then I'm just left with those who are in the park, right? Remaining in the park. So it says h of 17 is, they gave us a number, right? H of 17 is 37.25. So that means 3,725 people remain in the park at 5 p.m. Okay, does that make sense? All right, you count the number of people who've entered, you subtract all the people who've left, and what you have is the remaining number of people in the park. Okay, so now let's keep going. Now, the next question is find the value of h prime of 17. Okay, it's asking a lot here. We know it's derivative related. Well, before we find h prime of 17, why don't we find h prime of what? H prime of t. Yeah, let's find the derivative formula before we work in that 17. So h prime of t means I want to find the derivative of this integral. Now, does this remind you of anything? This notation here? What's going to happen if I put a derivative next to an integral? Cancel out. This is second theorem, basically, right? So second theorem says, okay, if I'm pairing a derivative on top of the integral, this wipes itself out. I mean, the upper bound gets inserted in, but I'm just left with this h prime of t. It's just e of t minus L of t.
So if I want to find h prime of 17, I would be E of 17 minus L of 17. Right, let's make the calculator find this value for us, right? We already have E of t in y1. I'm going to have L of t in y2. So I'm going to go back to my problem here and type in L of t. Now, if I just want to insert into the function without doing any derivative, I can just go to alpha trace, select y1, which is my E of t, and I just do parentheses 17. It's just going to plug that 17 in for all the variables for me. Minus alpha trace, y2, parentheses 17. Sorry, not y1, not y6. Okay, if we do math fraction here, I'm sorry, math decimal. All right, let's talk about what this means here. E of t and L of t, both of these are in terms of what? What are the units here? People per hour. So this is going to remain people per hour, right? That's not going to change. We didn't do derivative or integral. It's going to stay. So what does this mean? What does that negative 380 mean in relation to the park? Yeah, the rate of people who are in the park. So we know that at 5 p.m., we know the population is shrinking by 380 people per hour. Right. And I think that makes sense in our head, right? We understand that we can expect that to happen, right? Nearing the end of the day, the number of people who are in the park are going to become less and less because people are ready to go home. Okay. All right, any questions here? All right, let's look at part D here. At what time does the model predict that the number of people in the park is at a maximum? Okay. At a maximum. So when you think about a maximum or a minimum, let's say you think about a curve here. That's usually when what is equal to 0. If I want to find a relative max, relative min, I would set what equal to 0. Slope or derivative, right? Derivative equals 0. So I want us to kind of think about it from that perspective, right? We know what h of t is. Or sorry, we know what h prime of t is, right? H prime of t is this E of t minus L of t, right? And we're asking, well, what if I just set that equal to 0? Then I can find the maximum. But I want us to kind of make sense of this. Like, why is it that I can find my maximum just by setting my derivative equal to 0? Okay. So I want us to think about this. So E of t is the rate at which people are entering in the park. Okay. What's going to happen to E of t as the day progresses? It's going to decrease, right? If you compare 12 p.m. to 3 p.m. to 5 p.m., the rate at which people are entering is going to be decreasing. What about the people who are leaving as the day progresses? Increasing, right? There's no one who's leaving the park at 10 a.m. But by 3 p.m., 4 p.m., 5 p.m., you have more people who are leaving. So E of t is dropping, L of t is increasing. So where is the maximum number of people going to occur? When they're equal, right? Right before L of t overtakes E of t is when you're going to have the maximum number of people. Once L of t rises above E of t, then that population is shrinking, right? So that's why we're setting E of t minus L of t equal to 0. We're trying to find that balancing point where that maximum number of people is occurring, because as soon as it gets past that point, then the population is going to start decreasing because there's more people leaving than coming in. Okay, so that's the reasoning here. So we're going to set E of t minus L of t equal to 0. Now this is going to be hard to do algebraically, right? You look at your E of t and L of t. We don't want to be solving this and figuring out, when is that minus that equal to 0. We're going to make the calculator do it. So one thing we can do is we can graph this function. Okay, so I can, whatever E of t minus L of t, I'm going to graph that function and then look for what? What is that going to look like here? Equals 0 means that's when the graph crosses the x-axis. And that's my solution, right? Now, what would you expect if you just had to on a normal day at a theme park, when would you expect the maximum number of people in the park to occur? Yeah, somewhere in the probably early to mid-afternoon, right? Because early in the day, there's people probably more coming in, but then by 5 p.m. it's going to be too late. So I would say maybe in that mid-afternoon, early mid-afternoon. So that's what we can expect from our answer. Okay, so I'm going to graph it. So under y3, I'm going to say y1 minus y2. Okay, I'm going to create an equation of y1 minus y2. Okay, now I'm going to go up and I'm going to unhighlight the equal sign because I don't want to graph. I only want to see that graph of that third function here. Now you see how you have such large numbers here. Your graph is probably going to look like a vertical line because you're zoomed in so far. It's going to look like as if you're not going to be able to really see any curve in the graph because we're dealing with such a large number. So what we can do is we can go to window, we can increase our y min, y max like in the thousands and kind of zoom out just. I'm going to say from negative 1,000 to 1,000. Maybe that's overkill, but we'll see. I'm hoping to see some curve. That's. 615. Oh, okay. Okay, it's occurring somewhere in that 15 range, but if I adjust my y min, y max, so let's say negative 200, 200, or negative 500, 500. Yeah, there it is. I can see that intersection. So if I do that intersection, it's going to come out to be around 15, t equals 15, which is around 3 p.m. So that's when the park is at a maximum. So I went to Windows And I extended out the X min, X max, and I made the Y min, Y max negative 500 because we're dealing with the thousands. So we're not going to see any curve in the graph unless we zoom out on the Y axis. Okay, I know I'm running short on time, so we'll pick this up on Monday. I'm not gonna have this due on Monday because I want to spend more time with this. So, but I think we'll be able to make a lot more progress on Monday. Okay, go ahead and get your phones. Tomorrow morning, help session 7:15.